Okay, final problem number 13. We see another problem that involves L and T. And again, if this is bugging you, it's no big deal. Think of this as dy dx. Okay, so y matches with L. So dy dx is 1/9 times the quantity 81 minus y. There's nothing that says that you have to do things in terms of L and T. You can absolutely switch to y and x. Okay, so now we can work with this. And we have to move the dx over and the 81 minus y over. So we end up with dy over 81 minus y equals 1/9 of dx. Okay, so this 81 over 9 is similar to the y plus 1, 81 minus y is similar to the y plus 1 from problem number 12. When it comes time to do our antiderivative, okay, we're going to do natural log again. Okay, but this time, in essence, we have sort of u equal to 81 minus y, which means du will be the opposite of dy, which means we need a negative sign right here. All right, this minus sign is leading to that minus sign, which means we need a minus sign here, and we also need a negative sign there. So when we do our antiderivative, we'll have negative natural log absolute value 81 minus y. Make that a little longer. Over on the right side, we just have 1/9 of x. That's step 2, antiderive both sides. Plus c. There's step 3, done. Step 4, when we plug in 0 for x, y is equal to 9. If you did not change over, you're plugging 0 in for t and 9 in for L. But either way, what's going to end up happening is we have the opposite of the natural log of 81 minus 9 is equal to 0 times 1/9 plus c. So 81 minus 9 is 72, so we have negative natural log 72 is equal to c, which means that if we put this back into our function, we have the opposite of the natural log of the absolute value of 81 minus y is equal to 1/9 x minus the natural log of 72. This is not the prettiest of problems. I will definitely agree with you on that. However, it's been on the exam in the past, so let's be prepared. Here we go, final step. We've got to get y out by itself. So for starters, we have this negative sign to get rid of. All right, so natural log, absolute value, 81 minus y is equal to, that means we have to negate both of these. So this will become negative 1/9 x, and this will become plus natural log 72. Okay, now we can raise both of the sides of the equation up into the exponent of e. Doing so gives us 81 minus y equal to e to the negative 1/9 x plus natural log of 72. All right, and just like before, we can split this up into a product, e to the negative 1/9 x times e to the natural log of 72, and then the 72 can come down, so this 81 minus y is equal to 72 e to the negative 1/9 x. Okay, what we did with the 72 is the exact same thing as what we did with the 5 in problem number 12. We're almost done. Got to get y out by itself, so we got to subtract 81 from both sides. All right, so we have the opposite of y is equal to 72 e to the negative 1/9 x minus 81, and now we negate everything, so y is equal to negative 72 e to the negative 1/9 x plus 81. That's our final answer. It's pretty messy, but it's true. Again, our function is in terms of e. Domain will be all real numbers.